Okay, let's go and get started. This is going to be a relatively quick lecture today because I want to give you some lab time to work on Lab 2. So getting started with today, what we're going to do, well, first off, today's topics, we're going to review a few things. I'm going to go over Lab 2 with you, and then you're going to have lab time to work on that. So you should take advantage of that lab time. Don't blow it off and wait till later. Go and get started on that. If you get stuck, ask me questions, send me an email, and I'll be around to help you. All right, so let's get started. All right, so first off, quick review. We have been looking at variables and flow control statements. The two types of flow control statements are decisions and looping statements, and we've looked at both of those. The decision statements are if statements, which came in three variants: if, simple if else, and then if elif else. You can put as many elifs as you want, but each one has a conditional. If you remember, a conditional is like a comparison, like if X is greater than something, or if I is less than something, or if health is equal to 0, game over. So that conditional in that is always some kind of comparison operator or conditional operator. Now, the same is true for a while loop. A while loop works a lot like an if statement. The only difference is it will run the lines of code that are indented if the comparison or conditional is true. Anything that's indented underneath here. And then it'll jump back to the top and try again. So the only difference between an if statement and a while is the while loop jumps back up and tries again. Okay, last thing I'm going to review is break and continue. Break immediately jumps you out of a loop. Continue immediately jumps back to the top and checks the condition or comparison again. And those can be useful in certain situations, which we'll see later on in the class. All right, so now on to Lab 2. So Lab 2 requires you to complete two different programs. It's kind of a part A and a part B to this, or part 1 and part 2. But each program will be developed as a separate Python file. So you'll have two Python files that you're going to submit for this lab. And I would suggest naming them something that makes sense, like Lab 2A and Lab 2B. I wouldn't name them like Python program, other Python program, because it's going to get really confusing if you ever need to go back and look at them later. So try to be wise about how you name things. That's going to make your life a lot easier and my life a lot easier when I grade it. So I'd suggest just using like Lab 2, which is what we're doing, and then part A, call it lab2.py, call part B lab2b.py. So you need to write the programs. You should test them before you turn them in. And then to turn them in, you're going to make a zip file. Just drag both of the lab2a and lab2b Python files into that zip file, and then submit that one file when you turn in the lab. Okay, so as a quick kind of explanation, if you don't know how to make zip files in Windows, you don't need to install WinZip. You don't need to install 7-zip or ZipGenius or anything like that. You can do it right from Windows. If you have something that's Windows XP and later, which I hope nobody's using Windows 98 or Windows ME or something stupid like that. I don't even know if Python would run on those now. But in Windows, essentially, if you open a folder view window, which is, you can get a folder view window. Really, you could right-click on or click on a folder on your desktop, or that's a folder view. So anytime you have a folder view where you can see files listed and things like that, essentially you can navigate to the place where your Python files are stored, wherever you saved your .py files. And then what you want to do from there is if you right-click and say, there's an option that will come up in the context menu that pops up that'll say New, and then you can say compressed zipped folder. And if you pick that, that'll create a zip file, and it'll automatically highlight it so you can give it a name. So I would suggest giving it a name that has your name in it and the lab number. So for me, for example, it might be Yoast lab 2, or it might be Paul Yoast lab2.zip or something like that. In your case, don't put Yoast unless that's your name, and there's nobody in the class that has that name. So you would have, let's say your name is Smith, something Smith, you could put Smith lab2.zip. And don't worry about if you have the same last name as someone else in the class. Blackboard will still keep those things separate. So just you could also put your first name and your last name if you wanted to, or first initial last name. Just make sure you put lab2 somewhere in there so when I download it, I know what it is. After you've created that zip file, it'll be empty. There's not won't be any files, so just drag the .py files into there to copy them into the zip file, and then submit the zip file on the course site. All right, so hopefully a lot of you, that's just a review, a lot of you probably already knew how to do that, but if you didn't, just follow those steps, and that will allow you to do that. Okay, one additional bit of housekeeping information here that's important is every program that you write and submit should have a comment block at the top. And I don't need a really elaborate comment block. Like I know some teachers say, oh, you have to have every variable that you use described, and there's a bunch of stuff they have. Really, if it'll help you, go ahead and add additional things, but I want at a minimum the top 3 lines of every program you write to have your name, so you fill in your name here. The class, which in this case is ETGG1801.51. This is the section number. And then what lab it is, and in the lab number include the sub lab number as well. So for example, your lab 2A should look like this, lab 2B should say 2B, but don't just call both of them lab 2. So when I'm grading it, I want to know which one it is. I'll use that as part of the grading process. So make sure you have at least these 3 comments at the top, and then you'll put the rest of your code underneath that here. Don't put this at the bottom or in the middle, put it right at the top. So that's the first thing that when you open that file, you'll see that. And that can help you too, because when you come across those files or load them up later, you'll know what class it was for, you'll know what lab number it was. If you want to put a little description of the lab here as well, like the first lab, Magic 8 Ball or whatever, the second one, Guessing Game, you might want to put that as a reminder to yourself, but the only ones I really require are these ones. And if you don't put these at the top, and it'll make it more difficult for me to grade the things and grade them appropriately, and I will start taking points off if you don't have this at the top of your program when I grade it. So make sure that's at the top as well. Okay, let's take a look at the lab. So I'm going to go ahead and switch over to looking at the lab sheet here. Give me 1 second to switch the video input. Okay, so here is, let me move this over a little bit. Okay, so this is lab 2, which is kind of decisions and other flow control stuff in Python. Notice the due date, Wednesday the 23rd at midnight. And notice that I say stuff here that you're going to write several different programs. Each program must be fully counted with your name, the class name, section number, and lab number. It says date. I don't really require the date at the top, but make sure you get the 3 things we talked about at the top. Also, it says to get full credit, you have to submit it by this due date, and that should be plenty of time for this. We're going to have another lab next week, so make sure to get this done. And also make sure you put that comment block at the top. It says demonstrate your program. You don't need to do that because you're submitting it on Blackboard. But just go ahead and make sure you have the comment block, make sure both parts are done, and make sure it's in a zip file. Make sure you submit that. All right, so let's take a quick look at the 2 programs. The first one, you're going to write a program that prints out the name of the program and the programmer's name. That would be you. And that's going to prompt the user to type in a question. Once the question has been entered, the program should print out the question again on one line. That should say on one line, and print one of the 10 randomly chosen answers on the following line. So here's an example of the program output. Magic 8 Ball, programmed by, and this will be your name, not my name. I programmed it, so I put my name there. And then it says enter a question. So will the world end this year? Especially appropriate for a question to ask for 2020 with all the craziness that's been going on, election year and pandemic and all the other hurricanes and forest fires and birds and snakes and airplanes and whatever else. But notice what the program does. It says Magic 8 Ball answers, prints out your question again. Will the world end this year? It adds this Q on the front, and then it prints out the answer, of course. But if I ran the program again and asked it a question again, it might give me a different answer. It might give me yes or no, and you can make these the actual Magic 8 Ball answers if you want, the ones that are actually in the actual plastic toy that you shake and get answers from. Or you can kind of make them a little bit funnier if you want to, or add your own twist on it. But basically, this is kind of what your output should look like. Now, how are you going to go about solving this? Well, think about the fact that we want 1 of 10 different answers. And then think about that we looked at using the random module and the randint function in there to get a random number. If I were you, I'd look at the example we did with the coin flip in class where it prints out heads or tails when you run it. We're going to want to do something like that, but rather than just 2 choices, heads and tails, we're going to have 10 choices of what it can print out. And so that's a pretty good hint for how to solve that one. And how do you choose from one of 10 things rather than just 2 things? Well, rather than an if and an else, you would have if, elif, 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 and you'd have like 10 different choices there. So that should be a pretty good hint on how you do this. This program doesn't need a loop or anything like that. It just runs once and then it stops and it ends. All right, so that's program A. So program B is the guessing game program. And the guessing game program is a little more complicated. It's going to require a while loop, but let's go and look at the description of that one. So looking at the description of this one, it says write a program that allows the user to play a guessing game with a computer. I'm going to zoom out just a little bit so we can fit all of this on the screen at once. That looks pretty good. All right, so write a program that allows the user to play a guessing game with a computer. The program should select a random number 1 through 100. So notice, again, we know how to do that. It's going to be a random integer 1 through 100. So random.randint, again, being used here. And you're going to want it to guess or to pick that number toward the top of the program. So somewhere before it enters the loop that makes the game continue, you're going to want to have it pick that number. Next thing, it says the program should then prompt the user to enter a guess number. If the user guesses too high or too low, it'll print out an appropriate message telling them that they guessed too high or too low. And notice I have a hint there. It says hint. You'll use the input function to get the user's guess. In order to compare that to the number that was the random integer, you have to convert it to an integer. And remember, we have that int function that can do that. We actually looked at doing that previously in the last lectures. And we're going to need to do that in order to compare it to the random number. So the program must let the user continue to guess until they guess the correct number. So in other words, we're going to have some kind of loop that runs forever. But if they ever guess the right number, the program is going to tell them they got it right and it's going to end. So there's a good case of where you might want to use something like a break statement to say, hey, if the number that they typed in, if their guess was equal to the secret number, then print out the message that they got it correct and end. Otherwise, check to see if their guess was too high or too low. So what I would suggest doing on this is essentially, you're going to have some if statements. They're going to have to be inside the while loop. And one hint here is remember that the indentation level matters. So you're going to have a while loop that runs the main program, and indented underneath that, you're going to have if statements that inside of those have indented code as well. And you can really have as many levels of indentation as you want with ifs and whiles. They can nest inside each other as much as you want. But in this case, you're just going to need an if statement inside of a while loop. And that if statement is probably going to have an if the guess is correct, else if it's too low, else if it's too high. And then it's going to go back to the top and ask for the guess again. So what I would do to solve this is think about how you would play this game with with a friend. Like if you were the one running the game, you'd say, okay, I'm going to think of a number, and you'd remember that. Anytime you're remembering something like that, that's where you're going to use a variable. So you're going to remember that, and then you say, okay, give me your guess, and they're going to give you your guess, their guess, and you're going to say, okay, if that's equal, I say you won. You got it correct. And if they did not get it correct, then you're going to think, okay, well, they didn't get it right, so was it too low? If it's not too low, then it had to be too high, and you'll tell them whatever, whichever the case is, and then you go back and you say, okay, now guess again. And so the idea there is one twist on this. Notice that we have to keep track of how many guesses and print out how many guesses it took them. That can be something that's another case where we're going to need another variable. Every time they guess, you're going to add 1 to that variable. That's a case where you'd want to use something like plus equal 1. And then when they get it correct, it'll end. I printed out bye-bye at the end. But note that this is a while loop with if statements inside of it, some kind of break to get out of that while loop maybe. But that's essentially what you're going to do. Okay, now let me switch back to the presentation here for just a second. Okay, so we looked at the lab. Now, a few hints here. Think about the steps that you would need to do yourself to perform that task. So if you were the one being the magic 8-ball, what would you have to do? You'd have to pick a random number. You then have to have like a list of how that number was associated with what. If the number was 0, then say this. If the number was 1, then say this, and so forth. But think about how you as a human would solve that, and try to think like a computer, one action at a time. Don't think, how would you play the magic 8-ball? Well, I would just pick a random thing and I'd say it. Think about it like I'd pick a random number and I would take that number, and if that number was 1, I would say this. Otherwise, if that number was 2, I would say this. Otherwise, so think about, you have a 10-sided die that you're going to roll. And whatever number comes up, there's a message that you're going to say that goes with each of those rolls of that die. Another thing that I would say is don't necessarily try to write all the code at once and then try it. For these simple labs now, you might be able to do that, but when you get to a more complicated program later, there's a whole field of study called software engineering and project management. You'll learn about that later on. But when you're working on a large project, if you try to write all of it at once and get all of it working all in one shot, chances are you're going to have mistakes and you're not going to know where the mistake is. So it's better to evolve your program a little bit at a time. So get one feature working, test that. Okay, that works. Now let's add the next feature. Test that. Let's get that working. So an example here might be that guessing game. You might have it so you first get it to generate the random number. The next step would be to make the while loop that runs, and inside of the while loop make it so that you get the number correct. The other thing that I'd say is that test your program more than one time with different input each time. So run it, make sure that the guessing game seems to make sense, run it again, make sure, like pick a number that's too low, pick one that's too high, play the actual game and test it. And that's going to be important. So don't just run it once, and if it worked, hey, everything's fine. Make sure to test it multiple times to make sure it works. If you do run into a bug, don't panic. Don't freak out and, oh my God, the world's ending. My program, I'm going to destroy something in my computer. The nice thing about programming is it's kind of like a little sandbox for ideas. And so if you wrote your program and it didn't work and there's a bug in it and it doesn't do something right, just go back and look at your code. You can change the code around. You can add things and take things out and what they call it refactoring. You can do stuff in a different way. There are good ways to write programs, and then there are bad ways. We're going to talk a little bit about that more this semester. Is like some implementation might work. There might be a more clever way to solve it, a way that uses less code, or a way that's more efficient, or a way that's easier to understand. So make sure to look at that. And more than anything else, feel free to experiment and play. And do whatever you need to make sure your program works. But try to get it done, tested, and then remember to submit those by the due date. So that's it for today. Work on that lab. It would be a good idea if you actually put some effort in to working on that this evening. The cats are now fighting with each other. But it'd be a good idea to put that work in tonight. Try to get everything done. And send me a message if you have questions. Remember that I'm always available by text message or email. And if you're struggling with this, let me know and I'll come in. We'll spend some time in the lab together and I can help you with the code. If you're writing this and it winds up being just hundreds of lines of code, you're doing something terribly wrong. Both of these programs can be really short, like 1 page or less, really less than that, just like maybe 20 lines of code for each of these. So make sure to try to get that done. Work on the lab tonight. And next class, we're going to start getting into some graphics. So rather than just a text-based program where we're typing things in on the computer, we're going to have things where we can have graphics on the screen and we press keys and stuff moves around, and eventually we're going to have explosions and things interacting with each other on the screen. So we're going to get to that starting next week. But work on Lab 2, try to get that done so we can move on to the more fun stuff coming up. All right, that's it. Everybody stay safe, wash your hands, and I'll see you next time.